operations. This section is probably something 8th graders have dealt with already by now, doing order of operation problems. Something they've seen probably in 6th and 7th grade, maybe even back to 5th grade. The basic operations, I'll first ask them if we remember what are the operations that we typically deal with in math. And usually they'll be able to tell me, addition, subtraction, multiplication, division. And as I do operations, and when we're dealing with one of those kind of problems, we're trying to evaluate some kind of expression. And then usually they can come up with maybe that phrase PEMDAS, P-E-M-D-E-S, and I'll talk about, well, what do those stand for? P-E-M-D-A-S. P stands for parentheses, so in some kind of problem with a few operations to do to find the answer, I can usually look power. I'll take care of that next. Again, a phrase they're pretty familiar with, and if you're taking notes along with me, that is something I would like you to write down is PEMDAS, that acronym, and everything that those stand for. Parentheses, exponents, multiplication, division, these types of problems to follow to get the right answer. Now, as I'm looking at those, though, there is actually a few other things we need to know about PEMDAS that it's not just this straight particular order that I have to do certain problems in. For the most part, I'm going to find that are actually on the same level. If I run into a problem where I have those operations to here, multiplication and division. Really, when I have a problem where I have just maybe multiplication and division left in a problem, I don't necessarily have to do the multiplication before the remind us of a general order. Taking notes along with me, make some kind of note like that as well. These are really on the same level, multiplication and division. If I get to a point in the problem where those are the two operations that I have left, I don't necessarily do go left to right. Oops. In certain problems, it could be a situation where if you do the multiplication first, it could actually be wrong. So M and D, one thing to understand about that level, though, is they are on the same level. Once you get to those in a different color, but same. These two as well are actually on the same level. If at some point in the problem I get what to do is go left to right. So just kind of make a note somewhere of that for both. Acronym to help us remember a good order, but M and D and A and S are actually the same on the same level in terms of the order of operations we're going to do something. If I get to a subtraction. Now PEMDAS I feel like has been around for a while now in terms of talking about how to evaluate some kind of problem with a bunch of numbers in, a bunch of operations to do. Here at PEM, myself and the 7th grade teacher, 6th grade teacher, we've talked about another way to attack these kind of problems, which again, just to name a few things that we like about it, we're still going to get the same answer we do as if we use PEMDAS, which is good. It'll break all these bigger problems maybe into smaller parts where it's just little problems that are much easier for us to handle, and it's kind of a nice organized way to attack the problem as opposed to just going through PEMDAS. So it's a little bit of a new method we've been doing now for the last. The one that I've got up here does work great. So I'd look through it and I'd find the parenthesis part first, and then I'd try to find everything that I have to do with exponents, and then I try to go left or right with multiplication and division, and left or right with addition. Been working with recently to break this problem. Just notice how in PEMDAS, the addition and subtraction are at the very end, right? Those are usually the last two things we do. In this system, they're still going to be the last two things that we do, except we're going to break the problem apart. So like, for example, here's an addition sign. What I do, the addition sign, and I bring it down kind of like a little ways to give myself some room to work, but also just to visually show like I'm breaking this problem apart into different little groups here. I'm going to circle that's not inside a parentheses. So this one right here, 8 minus 6, I'm not going to do that one. That one, if it's in a parentheses, I won't circle it. But any other addition subtraction sign, if I was doing this sign with, or this problem with PEMDAS, they would be some of the last things that I would do. This is up and down all those addition and subtraction. So like I have one up here which is just negative 20 by itself. Then I've got a little problem right here, 48 divided by whatever I get out of that parenthesis. Then I've divided by 3 divided by 2. 5 squared is just a little problem. 35 times 2. I've broken this problem, and this will give me the correct answer. I've broken this problem, and it's just like 5 little problems. And what I'm going to do with all those, the answers to those little problems is just do my answers, just like I would in PEMDAS as well. I would do the addition or subtraction last anyway. But this grouping method will actually get me to the answer as well, and it's a nice way for students to visually, as opposed to seeing that big massive problem we've got up there. And what do I do next, and where do I go, and rewriting everything all the time. As opposed to doing that, this was a nice, easy way to break it apart into smaller steps for them, and it'll still get us to the correct answers on the next page. If you're taking notes along with me, then that phrase in red there is something that I would like you to write down. So just like I was talking about on the previous page, well, we're still going to do those operations last, but we're going to look at start. And they're going to form our groups to break the problems apart. And when we do this, and when students do this successfully, we have a better chance of not making as many little but still one I could do this system with. It says 3 times 9 minus 8 times 20 left to right, and said 3 times 9 is 27, minus 8 is 19, times 2 is 38, and took the answer and gone with that. But that's not the right answer. But by doing PEMDAS, they could get the right answer. But one way to this will stop. They still sometimes forget PEMDAS and like to go left to right. Instead, I just look at that subtraction sign, and this will ensure that I do the correct order of operations. Now I've just got 3 times 9, which is 27. Answer. So that subtraction sign kind of broke it into 2, and I do those 2 little problems. Same thing with the next one. I see there's a subtraction sign here and an addition sign here. Just addition and subtraction signs. Those are the only ones that I am going to drop down in this type of system. Nice thing is 15 is just the. Let's bring that down. Same thing with the 14 on the right. The only one I really have to worry about is 2 times 5, which is 10. That's the only problem I really have. Using a calculator if they want to just go left to right here now. But otherwise, a lot of these 15 minus 10 gives me 5, plus 14 gives me 19. Eighty-one plus 6 to the first minus 10 divided by 5 divided by 2. Right now, again, looks like there's a lot of things going on. I could definitely do PEMDAS. That would work. But a nice way to just break the problem apart to make sure that I do the problem in the correct order. Drop down addition and subtraction signs. Now I've made just 4 little problems. And again, so many students doesn't that problem as opposed to a 6-step problem, maybe what this problem would have been. But now if I break it apart, this makes it much more manageable, and it just looks easier too. Okay, it gives students more confidence because as you look at that, it's like, oh, well, I can for some. Well, in negative square root of 81, square root of 81 is 9, so that just means this is negative 9. That sign in front just means apply it and make it negative. And I do know that this kind of looks like because it is in front of that square. It isn't a subtraction sign. It just means make that number negative. Then plus 6 to the first power, any number to the first power is just that number itself. So that just ends up being 6. The system is what total, and that's what I put down here. So whatever that total is, that's where it goes. If I have a couple steps, I could show a little work right underneath, kind of like this. So if I'm doing division, I'm going left to right. And then I have to divide 2 by 2. My grand total goes at the bottom. Okay, as you can. But the grand total is what goes down here. As long as we do that, that will also help us get the right answer. Then just going left to right. $14 gives me positive 10. Again, I'm okay if kids use their calculator, but otherwise, it is just nice to be able to just add and subtract at the end of the problem. One more problem maybe, or one more example to go through here just to make sure we see something else that may happen, especially as we go on in 8th grade and up in grades for more problems this year and following years. So what happens when we have a parentheses in one of these types of problems? There's kind of 2 ways you could deal with it, but one way that I like is just think about, well, then I'm not going to drop down the parentheses that are in, or the plus and minus signs that are in a parenthesis. Again, think about what we're trying to do. We're trying to do PEMDAS, the last. Parentheses usually is one of the first things we do. So what I'm looking for is here's the subtraction. I'm not going to do that until the end of the problem. And this addition I'm not going to do until the end of the problem. So those I'm going to drop down. Since this subtraction sign's in parentheses, it's actually going to be one of the first things I do if I can. So that's why I will not drop that. Is I'm just not going to drop down the parentheses. Another way is I could just take care of the parentheses first and then see if that helps my problem. But I'm going to do it like this for this example. So I'm not going to drop down parentheses, or sorry, an addition or subtraction sign that's in the parentheses. So then, so how does that change anything? Well, then it doesn't really change any problems. And as you can see, really, the first problem here is just 50, the number itself. The last one is just 18, so nothing really to do with those outside ones, just the one in the middle there that I have to deal with. And now is where I can still remember PEMDAS. This is where PEMDAS will still be helpful. Well, as I think about going through PEMDAS, I have to do the print. The third power. So again, I can show a little work in here, but my grand total is going to go at the bottom. That's the important thing to remember. So as I'm keep going out through my steps, well, 2 to the third power is 8. So I did the exponent and then multiply. 8 times 5 gives me 40. So at the bottom there, that's our grand total for that little section, that little problem. 50 minus 40 is 10, plus 18 gives me 28. So I'm getting a final of 28. When students are using this system of dropping down addition and subtraction signs, is why we'd like to continue using this. PEMDAS is still very important. PEMDAS will still work as well. But as you can see, breaking the problem into little chunks helps a lot of students. So here's what, if you're working along with me, this is what I'd like you to work on as you're working through the problems today. Try to break them apart and use those small groups to help you get to the right answer.